Do you believe in God? Everyone may have their own answer. Some people believe in the existence of an all-powerful being who created the world, while others do not. The question of whether religious views align with current understandings of the formation and development of the universe is something each individual can freely consider. For example, the Catholic Church does not view the theory of evolution or concepts like the Big Bang as contradictory to its beliefs. Hello, everyone. Let's put aside the debates about religion. How would you react if scientists discovered something related to the birth of the universe? Welcome to Exploration Power. Now, let's verify everything. Let's get started. If you've ever heard of quantum physics, you may be familiar with one of its most important phenomena, wave-particle duality. This means that, at the microscopic level, a particle can be both a particle and a wave, depending on the conditions of observation. Wave-particle duality is closely linked to what is known as the observer effect. This is a phenomenon widely recognized, where the act of measuring itself can alter the value of a physical quantity. Typically, this is attributed to the limitations of measurement devices. For instance, when using a microscope to observe an object, light must be shined on it. However, photons from the light can interact with the object and change its state. Therefore, in science, when measuring an important parameter, multiple methods are often employed. However, the observer effect in quantum physics has a slightly different nuance. Recent discussions on science forums such as DC Inside, RulerWeb, Naver Cafe, and Client have raised a more provocative hypothesis. If the universe operates like a simulation, could there be a programmer behind it all? New discoveries revealing intricate mathematical structures embedded in the laws of physics, from the arithmetic found in physical constants to theories in quantum information, are prompting a growing number of scientists to seriously consider this possibility. So, what do you think? Is this evidence that our universe was designed by a higher intelligence, or merely a series of extraordinary coincidences? Share your thoughts below. Simply put, according to Heisenberg's uncertainty principle, the more precisely we measure one parameter of a particle, the more difficult it becomes to determine the other parameter. Before measurement, the particle exists in a superposition of all possible outcomes. But when the observer intervenes, the wave function collapses, and only one possibility remains. Clarifying terminology here is very important, which can differ from their everyday usage. The observer effect is no exception. Here, observer is not just a person looking at the particle. It also includes any measuring devices. A person merely looking at a particle without taking measurements, under this understanding, is not considered an observer. This also means that, in this case, the observer does not necessarily need to possess intelligence. Let's take a simple example. In everyday life, we often use measuring units like a teaspoon or a tablespoon. These units are not very precise but are very useful when cooking or measuring medicine. Typically, a teaspoon holds about 5 grams in powder form or 5 milliliters in liquid form. Now, imagine you place a teaspoon under the blinding light of a spotlight. At that point, a corresponding amount of water will accumulate in the spoon. In this case, the spoon acts as a physical observer because it helps determine the amount of water without human intervention. Of course, the spoon itself does not have intelligence. But in some way, the properties and behavior of the water molecules inside it have changed, leading to the collapse of the quantum wave function. At least from this point onward, the water molecules are no longer free to evaporate or spread across the asphalt. As a result, subsequent changes may occur. For example, the spoon may change color, or the bacterial concentration in the water may change. If instead of a spoon, we use a bucket of water, the entire bucket could become a small pond, where an independent ecosystem with algae and microorganisms might later form. Of course, there are many interesting quantum effects to consider, but fundamentally, this is how the observer effect works at the microscopic level. When a particle is measured and its state is determined, it changes its properties and behavior, potentially even contributing to the creation of a completely new entity. Once again, it is important to emphasize that the observer does not necessarily need to possess intelligence, and also does not need to be aware of the process. This is why theories in quantum psychology, where it is believed that if we want something strongly enough, the observer effect will make it come true, lack scientific basis. In other words, the idea that wishing for something will make it happen is as illogical as believing that a bucket can create water on its own, or that the amount of water in a bucket can change according to the will of its owner. Of course, we can actively pour more water into the bucket, but that has nothing to do with the observer effect in quantum physics. In conclusion, just because you wish for something does not mean it will automatically happen. Some scientists are debating whether the mathematical structure within physical constants might contain the signature of a superior intelligence. For instance, why do constants like the gravitational constant g, the speed of light c, and Planck's constant h hold values so precise that even the slightest deviation would make the universe, as we know it, impossible? And here lies the ultimate question. Are we living in a reality shaped by a supreme observer? Or is this universe simply a random assembly of physical laws? We often hear that wave-particle duality only applies to individual particles, not to larger objects that we can see with the naked eye. But in fact, this is not entirely accurate. On one hand, particles can behave as waves when they are part of a group. Ocean waves are a typical example. But on the other hand, quantum objects are not completely waves or particles in the classical sense. In any case, everything in the universe is made up of subatomic particles. In reality, the number of elementary particles is not large. They can be considered as the bricks used to construct various structures. Although iron and helium seem unrelated, the protons, neutrons, and electrons that make them up are identical. If each of these particles exists in a superposition of all possible properties, then before the appearance of the observer, the universe could also exist in a similar state. This can be compared to the image of a water droplet completely free before falling into the bucket, but once it enters the bucket, it becomes a fixed entity with new properties. Now, let's try to look at the birth of the universe from the perspective of quantum physics. Before the Big Bang, nothing existed, not even a vacuum, because a vacuum is still a form of space. This is why, immediately after the universe was born, it could expand at speeds far exceeding the speed of light. This means that the universe wasn't expanding into some external space, but rather, it was expanding from within, with every point in the universe acting as a center of expansion. However, even in the quantum mechanical vacuum state, there are still random fluctuations of particles, where particle-antiparticle pairs are constantly created. Under normal conditions, these particles and antiparticles quickly annihilate each other, returning energy to space. Therefore, no physical interactions can be measured. Scientists believe that the universe before the Big Bang may have existed in a similar state. However, a big question arises: can the concept of time apply to that state? If so, then it's possible this state lasted for an incredibly long period. But at some point, a pair of particles didn't annihilate immediately. This caused a massive chain reaction, leading to the formation of the universe as we know it today. What caused this to happen? It was the observer effect, the topic we've been discussing since the beginning of the video. This is a big question. Who or what is this observer? Remember that an observer does not necessarily have to be an intelligent entity. Therefore, concluding that scientists have proven the existence of God may be premature. There is one possibility worth considering: a black hole might serve as the observer. In fact, Hawking radiation is a phenomenon that occurs when a particle-antiparticle pair naturally appears at the event horizon of a black hole. But instead of annihilating each other, one particle is sucked into the black hole, while the other flies outward. This could be the process we are looking for. While a black hole does not truly measure anything, it has some basic parameters that determine its behavior: mass, charge, and spin. These parameters affect how the black hole restructures the space around it. We've said that the observer in quantum physics is essentially an entity capable of rearranging particles. And indeed, Hawking radiation and particle interactions may have played a role in triggering the Big Bang. But if nothing existed before, where did the first black hole come from? This question leads us to modern hypotheses about the universe before the Big Bang. According to some hypotheses, the universe we observe may not simply be expanding forever, but could be undergoing a continuous cycle of expansion and contraction. When a cycle ends, the entire universe collapses into a massive black hole. Eventually, this black hole explodes, marking the beginning of a completely new phase of the universe. The important thing here is that all information sucked into the event horizon of the black hole is not lost, but instead, it is preserved within. In other words, when the old universe collapses and the Big Crunch occurs, a massive black hole forms. This black hole retains all the data of the previous universe, acting as a backup. There is even a more precise way to put it. The moment the first black hole emits Hawking radiation is the moment our observable universe begins to form. At that point, the old data may have served as a blueprint for building the new universe. This leads to a bold hypothesis. The black hole could be the creator of the universe, the first cause of all existence. We could go further and draw profound philosophical conclusions from this hypothesis. But for now, let's pause the topic for today. If you enjoyed this video, don't forget to hit like and share it on social media. We look forward to your support. See you in the next video. Goodbye.